Alright, muchachos, in this video, you guys are going to learn how to break down Big Bang World applications into more manageable pieces, alright? And the program that we're going to be breaking down in this video is very simple in nature, but they should help you in all your future endeavors with the more complicated programs that you will make going forward in this course with Big Bang, alright? So this one's called Mushroom Walk, and all it does is that it just draws a mushroom starting from the left side of the screen, moving to the right side all the way until it walks off the screen, right? And the vibes that I'm trying to go for here is Super Mario Brothers. The power-up mushroom, when you hit a question mark block that spawns, right? That mushroom just keeps on going until it walks off a ledge. And as Mario, you're always trying to desperately chase it or something. The Goomba, right? The brown mushroom, the enemy, that one just keeps walking towards your direction until it either kills you or walks off a ledge, right? So I'm trying to emulate that same feel here. In this case, it's walking off the screen, but hopefully, this will get a feel for that, right? Anywho, how do you go from blank editor to the animation that we just saw, right? It's not clear from the get-go, and sometimes you just get writer's block. And that's what we're going to do in this video. How do we break down thinking about Big Bang World applications? So if you guys go to howtocode.pages.dev, don't worry, that'll always be linked in the description below. All right, go to the Big Bang World Apps section. All right, so first of all, why is it called a world application? Well, because it simulates things that we do in the real world. In the real world, we interact with it, we see things move, right? We see people walking and things constantly moving, and we hear sounds play. So that's why it's called a world program, because it's the synthesis of what we do in the real world, all right? And where does the world come from? Well, presumably the Big Bang. So that's the pun behind all the naming schemes here. Don't look at me, I didn't come up with it, so if you don't like it, I don't know what to say. Go yell at the authors, right? Anywho, it's probably not helpful for me to just type out the solution, right? And just do it all in my head, because you guys won't, know what to do, right? You guys probably want to see what my thinking process is. How do I come up with this stuff? What do I even do? What's the next step, all right? And that's, of course, what we're going to do in this video. So here are all the steps. Hopefully you will follow this for all the Big Bang applications that you will write in this course. So let's just get started with the first part. So domain analysis. So get out a piece of paper or just use this virtual notepad. I use tldraw.com. It's pretty good. All right. And we're going to sketch out the program scenarios. All right. So this may seem, a little redundant because you guys just saw the animation. And, you guys are probably thinking, hey, I'm already imagining it in my head. Why do I need to draw this out? Well, because brains are, very fickle machines of fallacy. So it's always better to just write things down and be very explicit sometimes. All right, so that's what I'm going to do here. All right, also, there might be a program that you're just thinking up from scratch, right? So, yeah. Anywho, let's just sketch this out. So this is the mushroom starting from the left side of the screen. All right, that's what it looks like there. So just 2 or 3 pictures will be enough. There we go. That's in the middle of the screen. That's the mushroom, guys. I'm sorry, my drawing is freaking terrible. And here it is on the edge of the screen. All right. Sometimes you need more. Sometimes you need less. Sometimes you just need to hone in on just one picture, etc. All right. But the point is just get things down so we can use this as a baseline to reason about things. All right. So, those are the 3 scenarios done. Let's move on to the next step. So it says identify constant information. All right. So let me just get my text tool here. So constant. All right. All right. Okay, let me just make this font bigger. All right, so what about these 3 pictures are the same, right? Try to pause the video and just come up with as many as you can. You won't get them all, but, just try to get as much as you can. Some evolve, from naturally writing the code and going, hey, right, this seems like a constant. And some we can just, rattle off the bat, all right? Let's pause and try to think about a few. All right, so I'm assuming that you guys took a good swing at it. So what's constant about these 3? What's similar? Well, the background is similar. We're not seeing like a cloud in the background that moves. So the background is similar. So let me just write that down. Background. All right. So the background is similar. All right. And what else is similar about these 3 pictures? Well, the mushroom, right? The mushroom, even though it moves, it's still the same image. So the mushroom is also the same across all of these. All right, so we can say the mushroom image. All right, so let me just Expand this font. All right, what else is similar? Well, we can see the width of the canvas. All right, the width and the height are also the same across all of them. All right, so that's another couple of constants. So the width and the height. Hopefully you guys can read my handwriting. I'm, writing with a mouse, so it's always gonna be terrible. All right. What else is constant? So the background image. Oh, what about the y coordinate? It's always at the center, right? So the y coordinate is always the same, right? So it's always like at the center. So the y coordinate is another constant. Coordinate, y coord. All right, so that's, I think, as much as I can come up with for now. We'll add some more later if we discover some when we type the code out. All right, so next step, identify the changing information, 1.4, all right? So what's changing about these three? So I'm gonna write down that, so changing, all right. Okay, so the changing information, try to guess a few, all right? 3, 2, 1, I'm assuming that you guys took a good swing at it. So the x coordinate is the one that's changing, right? Because it's moving across the screen. So the x coordinate. All right, and that's about all I can identify for now. This is not like an absolute, you have to get all of them right away, right? Just, a quick analysis to get some juices running in your brain. All right, so next is to identify the Big Bang options, all right? So if you scroll down, here are all the Big Bang options. So if your app needs to update automatically as time passes, use onTick. Display something, use onDraw. Change in response to keyboard press, use onKey. Mouse events, use onMouse, and stop automatically, use stopWhen. All right, so if we look back at our picture, it looks like it just moves automatically, right? I wasn't touching the keyboard and stuff at that time. So it moves automatically, so we will need onTick, all right? So I'm gonna write this down off here to the side. Let me call it Big Bang options. All right, so I'm gonna expand that. The font is always a little too small. All right, so onTick. Okie dokie. And we need to draw because we're gonna be drawing something on the screen, all right? Be drawing this animation. By the way, to draw is always absolutely required. The rest are optional, right? We must have to draw though, because if we don't, it's going to crash. The rest can be omitted, and it's just going to draw that, one empty still frame. But anywho, that is the domain analysis done. All right, so now we are in a better position to build the actual program than before. All right, so notice how we focused on what we can do rather than be obsessively compulsed with what we can't do, staring at a blank editor, right? That's why we have you do all these steps. You might not be able to write the answer to the function, right? The problem right away, right? The function definition straight away, but focus on what you can do, right? You can, write the signature, what it consumes, what it produces, a short description, some unit tests, right? Check specs, examples, etc. And the template as a bare minimum structure, all right? So that's why we have you do all these steps. As problems get harder, you'll see where its usefulness increases. All right, so let's build the actual program. So we're going to use this template, right? This is going to be true of all Big Bang programs that we will write going forward. This is the bare minimum structure. So let's use this as a starter. All right, so we're going to start off with the constants. So you're going to see some direct mappings of, all this analysis we did in code form. So first of all, let's just start off with the short description. So mushroom walk animates a mushroom moving from left side of the screen to right side off screen. Right side off screen. All right. Next are, let's see, 2.2 constants based on 1.2 above, right? Based on the sketch we did. So the width and height are constants. So I'm going to say the width. Define width, I'm going to say that's 500. You guys can make it anything you want. I'm just picking these numbers because they look good to me. So the width and the height, the width is 500, height is 400. Next is the y coordinate. So I'm going to check myself off for these. So y coordinate is always in the center. So you may be tempted to write, let's see, center y. right? 400, what's half of 400? It's 200. But we should always refer to the constant variable name, height. So in case someone says, hey, now the height is 200, well, this will automatically adjust and be 100, right? So one source of control, one change reflects changing everything else. All right, so let's just keep going. So is that all the constants yet? Let's see, center Y. Let's see, center Y, width, height, center Y. We still need the background, so let's get to that. So background is an empty scene of width, height, and then we're going to say light blue. All right, I'm going to run that and then type in BG here so you guys can see what that is. Just a blue box. All right, let's keep going. So that is done. Next is the mushroom image. All right, so I'm going to say mush image. IMG, and you guys can make this out of, you know, shapes like, you know, oval or something, circle, and you know, rectangle, but I'm going to use the image. I'm going to use the emoji of a mushroom. All right, and just a reminder that emojis are always strings. They're always wrapped in quotes. All right, they're not images. I know you guys are looking at an image right here, right? I'm seeing an image, but it's really a string. And I can prove this, right? Because there's an image how function, right, with a question mark here, that whatever you give it, it will determine whether it's an image or not. So is the Boolean true an image? No, it's not, right? So is the background an image, right? The BG, the big blue rectangle we saw, is that an image? Yes, it is, right? What about the image, my typing is terrible, of the, you know, the string of this emoji right here? Well, it's not, right? And likewise, if we just pass it on without the strings, it's going to look for a emoji variable and see the variable is not defined. So again, emojis are strings, right? So since this is a string, we can use the text function, and as always, try to right click and search this in the help desk documentation to see what it means. I'll make it 96, and we're going to say it's color of red. The last parameter doesn't matter in our case, but it needs the arguments. So I'm going to run this. And now it's actually an image, right? So we ask image of mush img. Yeah, now it's actually an image. All right, so let's just keep going. So mushroom image, and that is all the constants done. All right, so next is, so constants are done. Data definitions using htdw based on 1.3. All right, so what is a good data to represent the mushroom, right? Well, it's an x, right? An x position that changes, so a number, because we can do arithmetic operations. So let's do htdw, right? This is data definitions. So we're going to say the world state is now a mushroom, and that is a number. All right, so what's the interpretation? Well, this means the x coordinate of the mushroom. All right, so that's done. The data description, the interpretation, some examples. So, you know, you could write, you know, C1 or something as 0. Examples are kind of redundant here because, you know, it's just a range of numbers and they're not really meaningful numbers, really. Just keep going. So a function template that processes this data. So just a minimum structure of what processes a number. So mushroom temp, call it M, and that M is a number. We've got to do something to that number. We don't know what, but this is just the general layout of the function. And that is how to design data done. All right, so let's keep going. What is the next step? Let's see, data versus HTTP, functions using HTDF. All right, and then the main first, based on 1.3, 1.4, and 2.2. All right, so let's start with the main first. All right, so this is the main function. By convention, we always wrap the call to big bang in the main function right here, and I'll explain that shortly. So we identified the options needed, right? We only need onTick and toDraw. So we don't need onKey, right? Reactions to key presses or mouse events. So we'll delete these two, and also the stop when. All right. All we need is toDraw and render. So there we go. And I'm going to delete this right here. All right. So now let's keep going. All right, so to-do list entries for Big Bang handlers. All right, so here's the to-do list, all right? So Control F, and then you can write to-do. So we only have 2 functions now. And let's say I don't like the name of talk, right? It's just, ugh. I want to change that to update. So we can check syntax and then right click, rename talk to update, because that just sounds more better to me. All right, so we got to focus on the update function. Also, we got to change the world state right here, the signatures right here. So main is going to consume mushroom, and produce a mushroom. All right, and we got to change all this. So WS, the world state is now going to be called mushroom. So let's see. Don't replace those 2 parameter names. I'll go back to those later. Replace, and replace. All right. And I'm just going to fix the signatures here. Okay. And let's see. Render consumes mushroom and produces an image. All right. So let's just work through the to-do list entries for these functions. All right. So let's start with update. So we go back to our drawing, right? Our analysis. X is the only changing coordinate, and it's increasing because X increases this way, right? And just a reminder, this top left corner is 0, 0. So there's an X of 0 and a Y of 0, right? It's not like classic algebra where you do like your X is like here, and then going up is adding Y, and then going down is negative Y. In this case, it's the opposite, right? Because going down is adding Y and going up is negating Y. So anywho, we're just going to be focusing on X right now. So let's do the htdf, right? htdf for these to-do list Big Bang handlers, all right? We're going to be working through this wish list. Okay, so let's see. Update is going to produce the next X coordinate of the mushroom. All right, so that's signature, that's purpose, and then next to the stub, so since it consumes a mushroom and produces a mushroom, we know that mushrooms are numbers, so we can use 0 as the dummy stub value, so we can run our test. All right, so that's done. Next are the examples. So check expect update of 0. Let's see, let's just add 1 to the current position, right? The current position is 0, we're going to add 1 to it. Likewise, if it's, 100, we want to add 1 to it. All right. So that seems pretty sufficient. So those are the examples done. Next, let's get the template. So here it is. I know the template is really boring for now, but we're going to see some more interesting examples in the future shortly. All right. So this is going to be update, and it's going to consume the mushroom. And we're just going to add 1 based on all we wrote so far. We just got to add 1 to the current position, which is M, which we're given M, all right? The current position. So +1, and we should be done with this. So we Control R to run it. The test should pass for this. And so they do. All right, next, let's move on to the render function. So this function's job is to draw the mushroom at the given coordinate, X coord. All right, so what's a good stub for this? Well, consumes a mushroom. So we'll call this M for mushroom. And then it's going to produce an image. So we can use empty image as the stub. All right, so now let's do some examples. Check expect render of, let's see, we're going to say render 0, right? What does that look like? Well, it's going to look like a place image of placing the mush image. Let's see, 0 in the X, center Y, and then let's see, what else? The background itself. All right, so we run this. We're going to see the image shortly. And it looks like this, right? This empty stub does not match this, which is fine, right? We just want to run the test to make sure that there's no errors. All right, let's do one more example here. So we're just elaborating things and building mental scaffolding here. So let's see, what does it look like when it's, when the render function is given 100? Well, we want to place it at 100. All right, so there we go. What does that look like? Somewhere like that. All right. And you can do one more example for all the way towards the end. So, let's just do that. So what happens when it's at the max width, right? What happens if it's here, which is going to be 500? That's what we decided on. So width. All right. All right. So this, we should also be given the width, right? And then we should just produce the width here. Place the image at the width. When given the width, place the image at the width. All right. Okay. So hopefully this is enough mental scaffolding, right? So now let's write the function. So we're going to do something to m. And looking at all we did before, looks like we're going to do the place image of the mushroom and let's see, place the image of the mushroom, mush img, at the given m, right? This is the given x coordinate that we're given, at the center y of the background. All right, so now all the tests should pass. And so they do. All right, so that's done. That's done. And now we got a test, review, and refactor. It all looks good to me. All right, so now let's look back at our steps. Let's see, So we did the two list entries, we worked through all of them, and we did the main function. So let's finish the main function. So we want to start the world with 0 because that's going to be the given x coordinate of the mushroom. So we want to start it always at the beginning. So mush of main of 0 should produce the animation like so, starting at 0. So this was 0, and then slowly moving across. All right. So that is pretty much it. So if we look back at our diagram here, right? The x coordinate is the only thing that's changing. So that helped me, realize, hey, we got to do something with the given changing x coordinate right here. And likewise, we had to change it and update it here. All right. So that is pretty much it. So now let's say that, hey, it's moving a bit too slowly here, right? When we run the program, it's just moving like at a snail's pace, right? We can change the speed right here because this one is what updates, increments the position, right? In fact, we can do better and call this speed and then define a speed up here as a constant. So define speed, we'll say move at 3 pixels per tick. All right, and that should be a lot better. We also have to update our test here also. So as you can see, it's no longer 1. 1 is no longer the speed. It's going to be 3. But instead of 3, we should use the constant variable speed. All right, so now anytime we change the speed, so if we want it to be like 100, it will just automatically adjust in our tests. All right, so that's even better. Okay. So now lastly, I would like to remind you guys is Racket can deal with images in code. So I'm going to copy this Goomba emoji and I'm going to paste it into Racket. All right. So define Goomba is going to be equal to this. Oh, that's not the image. We have to drag it actually. I think we have to drag it in. Or there's like an insert right here. So insert image and we can pick this Goomba. So there we go. All right, so I'm gonna run this. So that Goomba is like 16 by 16 pixels, right? So image width of Goomba, right? So I'm gonna scale that to 96, which is, what is 96? 96 divided by, divided by 16. What is that? Oopsie daisy. It is 6. So I'm gonna scale this by 6. Scale this by 6. There we go. All right, because it's very small. Scale expects a real positive number as its first argument. Whoops, I need to switch these around. So you need to go first, and then the image second. All right, so Goomba. All right, so there's a Goomba. Let's comment the original mushroom image out, and then rename this to mush img, and run this. And now we should see the actual Mario Goomba walk across the screen. All right, so by typing main at 0, there we go. Right, there it is. All right. The reason I don't like images in code, I mean, it's fine in this case because we're just doing it with these programs. But if we open it up with Notepad, so I'm going to do notepad, let's see, mushroom walk racket. Right, actually, where is this file? Mushroom walk. All right, so is it in downloads? Mushroom walk racket. So there we go. Here it is. All right. So as you can see, it's unreadable. You have to open it up in DrRacket in order to read this file like this, right? Where you can see all the variables, names and stuff. If you open it up in Notepad or VS Code, it's going to look like this, right? We can see part of it, right? Here's the check specs. Here's the render function. Here's the center Y and stuff. But yeah, this is the only reason why, because I don't really use DrRacket when working with Racket files sometimes. Also, it's kind of hard for the auto grader, the web grader, to deal with these files. But hey, if you want to make, you want to paste images in here for your programs, that's all good to me. All right. So yeah. All right. So you guys learned a lot in this video. You guys learned how to piece together a Big Bang program and replicate something that you just saw, like an animation on screen, and try to work that out on your own. You also learned the process of how to break down Big Bang applications into more manageable pieces, right? Doing the domain analysis, focusing on what we can do, and using it as a mental scaffolding to leap off intuition. All right. And lastly, why do we have to call main 0 here, right? What if you're making a Big Bang application and you always want to run it when you hit the run button? You don't want to type in main 0 like this all the time just to run this. You can just call it down here like so. All right. And then Control R to run, and that should just pop it up automatically. All right. The reason why we don't do this is because what if we just want to run the test and then, the window just keeps popping up and you're like, go away. I just want to be able to focus on just the render part because, maybe that's the part that's buggy, or I just want to focus on just the update part. So that is why we wrap it in the main function. But you learned a lot in this video, and hopefully you will use this in all the future Big Bang problems as we go forward in this course. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.